In this sublesson, we are going to see how to configure IGMP and PIM to build a multicast topology. For the demonstration purpose, we have a simple topology where we have a source and receiver. NX1 and NX4 are acting as the FHR and the LHR. NX2 and NX3 are the intermediate routers or switch, and NX10, which is the rendezvous point. Let's look at the devices. We'll begin with NX1. In this, let's look at if we have the PIM configuration available. Show run PIM. And again, we got an invalid command. That means the PIM feature is not enabled. So first thing first, we go into the config mode and say feature PIM. This will enable the PIM feature on the device and will allow us to configure PIM sparse mode on the Nexus switches. Then we look at the interfaces which are enabled on the router. So show IP interface brief. And we have VLAN 100. The VLAN 100 is connected towards the source. This is its own loopback 0. Ethernet 1/1. So Ethernet 1/1 is connecting to the upstream switch. So we go into interface Ethernet 1/1, say IP PIM sparse mode. And on the interface VLAN 100, we say IP PIM sparse mode. So we have enabled PIM on NX1. We then go to NX4, which is the device connecting to the receiver, or the LHR. So if I do show run PIM, PIM is not enabled. So we go into the config mode, feature PIM, and do show IP interface brief. OK, so we have two interfaces which are connecting to the receiver. One is 172.16.124.4 and 172.16.142.4. The Ethernet 1/1 is the device which is connecting the upstream switch. So we get into the interface configuration mode, interface Ethernet 1/1, say IP PIM sparse mode. Now we have enabled PIM. Now remember that we don't really need to specifically enable IGMP. The IGMP is enabled by default. So if I do feature IGMP, you don't get an option because IGMP is enabled by default on the Nexus switches. The IGMP request is being sent by the receiver. So we don't have to enable anything here on this Nexus switch. All it needs is reachability towards the source and to the RP. Now at this point, we haven't so far defined the rendezvous point. The rendezvous point, based on the topology, is on NX10 RP. So let's look at the PIM configuration. So PIM is not enabled here as well. So we go feature PIM. And we look at the interfaces, show IP interface brief. Let's make loopback 0 as the RP. So we say IP PIM RP-address 192.168.10.10. And we get into the Ethernet 1/1 and 2 and say these are the links towards the downstream switches, which is NX2 and NX3. We enable IP PIM sparse mode. We can enable it on the loopback interface as well, so IP PIM sparse mode, and we are good here. Now since we have used this configuration, IP PIM RP-address 192.168.10.10, this means we are using static RP configuration. If we are using static RP, this command needs to be configured on all the switches from the source to the receiver. So we go on NX1 and enable the RP configuration. And we go on NX4 and enable the RP configuration here as well. So we now have the RP configuration done on both the first hop router, the last hop router, and RP is enabled on NX10 RP. This is how we build the multicast topology. If you're not interested in using the static RP configuration, if you have multiple rendezvous points which are serving different multicast groups, in that scenario, you can have two different kind of RPs configured on the same box or in different boxes. So in this case, what we can do is we can configure IP PIM RP-address 192.168.10.10, and you get an option to specify the prefix list or the route map or the group list for which you're defining the RP statically. If you configure IP PIM auto RP and do a question mark, you will see under Auto RP, we can see multiple options. Forward, listen. Make sure when we are enabling Auto RP, the Nexus switches are enabled to forward or listen for Auto RP announcements. Once we have configured the device for forward and listen, on the rendezvous point, we can say who is going to be the RP candidate. In this case, if it's our loopback 0, we can say RP candidate and specify the interface, say loopback 0. And this should take care of configuring Auto RP. But for now, since we are using static RP, we'll get rid of this configuration. And let's move on to the next sublesson to see how the multicast path is built and how multicast traffic is being forwarded across this multicast topology.